Okay, here we have equations with logarithms, and then in these next few videos, they're going to be simple log equations. We've got a logarithm base 17 is equal to another logarithm base 17. So when you have a logarithm equal to another logarithm, and they have that same base, so you have one logarithm equals one logarithm, you can set their arguments equal to each other. Then x has to equal y. So if I have log base b of x is equal to log base b of y, then it makes sense that x has to equal y. So that's what we're going to do. We're going to check to make sure that they have the same base. Log base 17, log base 17. I have one logarithm on the left, one logarithm on the right. I can now set their arguments equal to each other. So negative x plus 9 is equal to x plus 1. The thing is that remember the argument has to be greater than 0. The argument has to be greater than 0. So whatever we solve for, we're going to have to check to make sure it doesn't cause a problem in that argument. And if it does, then it's called an extraneous solution. So we're going to add x to both sides. And I get 9 equals 2x plus 1. I subtract 1 from both sides. 8 equals 2x. Divide both sides by 2. And x equals 4. When I put a 4 back into this argument right here, 4 plus 1 is positive, so that works. When I put a 4 over into this one, I get negative 4. The opposite of 4 plus 9 is 5, so that one works. So when I put 4 into this one, I get an argument of 5. When I put 4 into this one, I get an argument of 5. 5, 5. That works. So x equals 4. Okay, let's try again. We've got 1 natural log is equal to 1 natural log. Therefore, their arguments have to be equal to each other. So 2n plus 10 has to equal 3n plus 1. I'm going to subtract 2n from both sides. 10 equals n plus 1. I subtract 1 from both sides. 9 equals n. I put the 9 back in. 2 times 9 is 18. 18 plus 10 is 28. So that would give me a natural log of 28 on the left. I put a 9 over here. 3 times 9 is 27. 27 plus 1 is 28. I'd have the natural log of 28. The natural log of 28 equals the natural log of 28. 9 is an answer that works. Okay, you try this one. So press pause, and then when you're ready to check your answer, come on back. Okay, welcome back. Because they're both log base 16 is equal to 1 log base 16, the arguments must be equal to each other. So we have r plus 1 equals 2r. I subtracted r from both sides. I get 1 equals r. When I plug that back in, it keeps the first argument positive. And when I plug the r back in over here, it keeps the second one positive. So r equals 1 is our solution. Now in the next video, we're going to solve when the variable is in the argument. So here's when the variable is in the argument. So I don't have 2 logarithms equal to each other. I've got a different type of setup here, but I still have that variable in the argument. So I'll show you that in the next video.